Hi, so in the last video we looked at basic skills that you need to solve problems in analytic geometry. We looked at midpoint, we looked at finding the slope of a line and the perpendicular slope of a line. We're going to put those skills together in this scenario to find the circumcenter of a triangle. And circumcenter is very useful because it is the point that is equidistant from all three corners. So if I was to measure these distances here, that should be a straight line, then these distances would all be the same. And that's pretty useful in applications where you're trying to triangulate something that you want to be equal distances. It's also worth noting with circumcenters that you can actually have the so-called circumcenter with relation to a triangle can actually be outside the triangle. And the reason for that is because what you're really finding is you're finding the center of the circle that circumscribes this triangle. So if you draw a kind of really thin, scalene triangle there, you will see that this point here in the middle, it is still equidistant from the three corners. So it's equidistant, it is the equidistant point, but it's actually outside of the triangle. So keep that in mind. That can happen, particularly if you've got a triangle that is very far from being equilateral or isosceles. So it's usually with these kind of extreme scalene triangles like this. But I suppose technically, if I was to draw something like this, yeah, the same thing could happen. It's all going to depend on how that triangle is drawn. Okay, so practical application of this, let's imagine an engineer wants to place a cell phone tower in such a position that it provides equal coverage and power to these three towns in the area. So you can triangulate the position of where that should go using grid references here. So let's imagine this is town A, this will be town B, and town C. So let's do a graphical visual check. So this will confirm for you where roughly the center should be. So you can use that circle idea that we looked at, and you can draw, oh dear, you can draw better than me probably, a circle around that triangle, and you can visually verify here that, yeah, I think it could be one of those scenarios where the center is technically outside the triangle, maybe somewhere around here. So let's go to the algebra, and the algebra will tell you exactly what that center is, and that's the advantage of the algebra, right? It doesn't depend on the accuracy of your measuring tools or the person doing the measuring. We can numerically find the exact center. How do we do that? So in order for that to work, we're going to need to find the perpendicular bisectors. I mean, you can just draw these in anyway. You could just measure this, and then you could use a set square. So midpoint and then set square to do a perpendicular bisector, and you could locate pretty well the circumcenter of the triangle, again depending on how accurate your grid is. Let's look at algebraically in this problem how you're going to find the equations of those perpendicular bisectors, and we'll find the intersection of those perpendicular bisectors, and that will be the exact circumcenter. So I'm going to focus first of all on this one here, AB. So in order to find the equation of the perpendicular bisector to that, I'm going to need the slope of AB, and I'm going to need the midpoint. So let's start with the easy stuff first. The midpoint is the average of the x coordinates. So I'm just going to add those x values together. So that's xy, that's xy. So do that. Y values 5 and 0 over 2. So the midpoint is minus 2.5, 2.5. Okay, I'm also going to need the slope of AB in order that I can find the slope of the perpendicular. So slope of AB is just the difference in the y values. Remember that The point on the right is x2, y2, and the point on the left is x1, y1. So in this particular example here, I will be working with 5 minus 0 over 0 minus x1, that's 5, and what have I got there then? I found the slope to be, sorry, this should be minus and minus 5. So what I've got there is actually just 5 over 5. So my slope is 1. And that makes sense visually, doesn't it? Because you can see here, yeah, you're pretty much going across 1, up 1. So again, sorry there, that should be minus and minus 5, because in the formula you're subtracting, and then you're subtracting a negative 5. If m1 is 1, m2 is the negative reciprocal of m1. In other words, in this case, it's minus 1 over 1. That makes sense, doesn't it? Like if you were looking at this perpendicular bisector, minus 1 slope, meaning for every one you go across, you go down 1. Okay, so those are the ingredients we can use to find the equation of the line. So the equation of the line that we're trying to find, we just need to sub in our values into this equation here. Let's just go to the next slide there and do that. Okay, so what did we say? We said the slope that we're using is minus 1, right? The midpoint was minus 2.5, 2.5. So I'm going to use that as the xy values. And I'm going to drop these values into y equals mx plus b. So I've literally got 2.5 equals negative 1 times negative 2.5 plus b. B is therefore 0. You can see that's just going to give me 2.5 here, right? So b is 0. So the equation of this perpendicular bisector here will be y equals mx plus b. So that's minus x plus 0. So it's just the equation of the line y equals minus x. Okay, so I've got the equation of one of the perpendicular bisectors. What I'm going to do now is work on side BC and find the equation of that perpendicular bisector through here. So let's go to another slide. Okay, so now I'm focusing on these points, 0, 5, 5, 1. And it's just exactly the same procedure. So I am going to find, let's do the easy stuff again first, which is generally what I recommend doing in math. Get you started. So I'm just going to average those. I'm just going to do that in my head. You can see the average of 0 and 5 is 2.5, right? And the average of 5 and 1, if I add those and divide by 2, is 6 divided by 2 is 3. So that's the midpoint. I'm going to need to find the slope of BC. So with slope, make sure again the point on the right is the one you label as x2, y2. So it's the point on the right, subtract the point on the left. So difference in the y values there. Okay, what have I got here then? 1 minus 5, and I've got 5 minus 0. So I've got minus 4/5. So if I was to do minus 1 over the reciprocal of that, I would get positive 5/4. So a kind of quick, easy trick if you get a fractional slope is just to say the reciprocal slope is just turn the fraction upside down and change the sign. But it's the same result as if you had done this, right? If you had done that, you would be doing minus 1, then dividing by minus 4/5 is multiplying by the reciprocal. Okay, so thinking about the equation of a line, let's drop these values in. So there's my xy. So I got 3 equals this slope, because I'm finding the perpendicular line, times the x value 2.5 oops, that's an ugly mix of decimal fractions there. Let's just turn that decimal back into 5/2, shall we? And it's going to write here, I should get 3 equals 25/8 plus b, and then b, subtract that. So that's minus 3 and 1/8. So b is minus 1/8. Okay, so it's going to scrub a little bit of this. A bit of space here. So the equation of that perpendicular bisector now is going to be using that. Equation of perpendicular bisector is y equals 5/4 x minus 1/8. Okay. Okay, that's that line. And we already found the equation of this one, minus x. So what I'm going to do now is I'll find the intersection of those two lines. This was just a graphical check I did in Geogebra to confirm that I was on the right track. Geogebra is a free version of Geometer Sketchpad, and you can just basically plot a triangle, put in line segments, and Geogebra can locate exactly for you the midpoints and can put in perpendicular bisectors, and yeah, it confirms we're definitely on the right track. We're just going to find that exactly because we've got two equations here. I used these two equations. They're both equal to y, so they're both equal to each other, right? So what I normally do in these kind of situations, because I have gradient form, I'm just going to say, it's like a form of substitution in a way. I'm just going to say one equation equals the other equation, or subbing out of y for minus x. Okay, let us solve this. So collect your x terms together. Sorry, excuse me, I'm just going to jump over here now. So what have I got here? Minus 1 and minus 1 1/4 is minus 2 1/4. So minus 2 1/4 x is minus 1/8. Let's make that mixed, top heavy fraction. So this, and then we've got minus 1/8 divided by minus 9/4 is the same thing as multiplying by 4/9, 4 of a negative 9. Well, it doesn't really matter where the negative is in there, as long as you have got the negative and you cancel it, so you actually get 4 out of 72, or I guess you can reduce that. Was that 1/18, I think? Yeah. So that is the x value of this point here. We're not finished, of course, because we're finding a coordinate, so we need the y value that pairs up with that x coordinate, right? So if x is an 1/18, let's go to our equations. Now you might as well just go to the easier equation when you're trying to find the y value. So this one is just simply y equals minus x. So therefore y is minus 1/18. You could verify if you want to be sure, like also take x is an 1/18 and plug it in there, and you should get the same value for y. And Geogebra does confirm that. So that is finding circumcenter of a triangle. Thank you.